Hey guys, welcome. Yeah, so if you're not familiar with my videos or the structure of my examples, example 0 is always talking about the concept or the idea before actually working on example. So example 0 is frequently a proof or a thorough explanation of the concept. And such is the case here. Here we're going to talk about the motivation behind the variable substitution y equals v times x when we're solving differential equations. And I call it variable substitution because v here is a variable. It's not a constant. And this substitution is very handy because it takes a given differential equation and makes it a separable equation. Yeah? Okay. How exactly? Well, in a video I made recently, we said that a first order differential equation that could be written in the form dy dx equals f of y over x is homogeneous first order differential equation. In other words, if you can write it this way, then it's homogeneous. Why do we care? Well, if you can write it this way, then you can use this variable substitution to turn the differential equation into a separable one. And so what we're going to do in the rest of this video is show how this variable substitution y equals vx turns a differential equation that could be written in this way into a separable equation. Yeah? Okay, cool. First, notice that y equals v times x means v is equal to y over x. So here, f of y over x is going to turn into f of v. Okay? Furthermore, y equals v times x means that dy dx, by applying the product rule on the right side, will equal, dy dx will equal v prime times x plus v times x prime. That is, dy dx will equal dv dx times x plus v times dx over dx. But dx over dx is just 1, so we don't need to bother. So this is it. dy dx will become dv dx times x plus v. Now, anytime you make the variable substitution y equals v times x, you need to write dy dx as this right-hand side. So don't reinvent the wheel, just use this. In other words, you'll have to do this over and over. Don't start from scratch, just start from here on the left side in place of dy dx, right? dv dx times x plus v. Okay, cool. And then, as I said, the right side, f of y over x, using this substitution, will turn into f of v. Okay, cool. Right? That's that. Y equals vx means y over x is v. And so then our differential equation now can be written as dv dx times x plus v equals f of v. Look, we only have v and x. That's not just what's nice because we only had y and x to start, right? What's nice, right, is not just that we have two variables, because as I just said, we had two variables to start. What's really nice is if we subtract v over on the right side, then it's pretty easy to see how we've got a separable equation here. This is the separable equation that it turns into. Yeah? Cool. All right. So this is why the variable substitution y equals vx is useful, and this is why we care if our differential equation can be written in the form dy dx equals f of y over x. In other words, this is why we care if it's homogeneous. Yeah? Okay, cool. All right, examples 1 and 2 to follow. And like I said, you can use the old example 4 from my separation of variables video series as your example 3 for the variable substitution y equals vx. All right, I'm out. I hope you enjoyed this. Take care.